Hello YouTube, we're back. All right, here's our solution for 2016 AB3 BC3. Now this is in the part 2B, no calculator. And this particular question really involves no calculator at all. The functions are all given geometrically. So this is just a quick summary without SAGE of how to do AB3 BC3. Okay, so the figure above shows the graph of a piecewise linear function for f. For x between -4 and 12 inclusive, the function g is defined as g of x equals the integral from 2, the definite integral from 2 to x of f of t dt. Does g have a relative min or max or neither at 10? Justify your answer. Well, to find mins and maxes, we usually look at g prime, right? If we're finding mins and maxes of g. Now, g prime, according to the fundamental theorem of calculus, part 2, is f, right? F of t composed with x. So, if f is the graph, g prime of 10 is 0. So there's a critical point. Remember, the first derivative test says where the derivative changes sign, you can have a min or a max. If it changes from positive to negative, it's a max. If it changes from negative to positive, it's a min. But where the critical points that you check, where the g, in this case, g prime is 0 or undefined. So g prime is 0 at 10. But g prime is f, and f before 10 is negative, and f right after 10 is also negative. So there is no min or max, it's neither. So let's write that. All right, so let's say number 3a. Let's see, 2016 AB3 BC3, okay? 3a says to look at the critical points of g. So if g of x is the definite integral from 2 to x under f of t dt, then g prime let's see, how about if I do this one? Then g prime of x is f of x. Okay, so if we do a little sign line, we had a critical point at 10 where g prime is 0, and for x values less than 10, g prime was negative, and for x values after 10, g prime was also negative. So g is decreasing and then decreasing again. That's not a min or a max, so say neither. You should also write a little sentence describing what the sign line is telling you. But the answer is neither. Is there min or a max at 10 or neither? And it's neither. All right, 3b. Does the graph of g have a point of inflection at x equals 4? So now we're looking at g double prime. And to find if we have a point of inflection at g double prime, we're looking for the critical points of g double prime where g double prime is 0 or undefined. So at 4, g double prime would be f prime, right? If g prime is f, g double prime is f prime. Now take a look at f prime at 4. At x equals 4, f prime does not exist, right? Because there's a corner there, right? So the derivative, the definition of the derivative as the limit would not exist. From the left, it's a positive slope. From the right, it's a positive slope. So the limit at 4 does not exist. Okay, so that's an undefined g double prime. But we're looking at f prime, which is the slope of this curve. And before x equals 4, the slope is positive. And after 4, x equals 4, f prime is negative. So it's changing from concave up to concave down, right? Okay, so let's say that. We're going to say, okay, 3b. Well, if g prime is f, then g double prime is f prime. So if you do a sign line test at x equals 4, g double prime is undefined there. At x equals 4, but for x less than 4, g double prime was positive, and after 4, g double prime was negative. So g itself has concave up and then concave down. Whoopsie. So write a little sentence saying that there is a point of inflection at x equals 4 on g of x. If you actually graph the g of x is the definite integral from 2 to x of f t dt. And don't forget, you have to write a little sentence that's describing what the sign line is telling you. We have a point of inflection of 4 because g double prime is changing sign, and have g G double prime at 4 is undefined. Alrighty. Part C, find the absolute min or min and max values of G on the interval from -4 to 12 inclusive. Justify your answers. Now remember the candidate's theorem, also known as the closed interval theorem, also known as the min-max theorem. This is such a famous theorem, it has a million names. That says where you're looking for absolute mins and absolute maxes on the closed interval, at the critical points where where in this case G prime is 0 or undefined. Remember, G prime is F. F is defined everywhere, but it's 0 where? At -2, at 2, at 6, and at 10. And also check the endpoints, because you could have an absolute max at the endpoints or an absolute min. So let's do that. We're going to make a little table. There it goes. Okay. All right, so what are the critical points? At x equals -4, what are we evaluating? The area from 2 to x between f of t dt and the t-axis, right? Okay, so what is that? Well, -4, and then we're going to do -2 and +2 and 6 and so forth. So what is the area from 2 to -4 under f of t dt? Well, isn't that the opposite of the area from -4 to 2, right? Isn't, when we do the area, a definite integral from a to b, a should be less than b, right? All right, so let's take a look at the area from 2 to -4 and then change the sign. All right, from 2 to -4. From 2 to -4, well, look, the area between x equals 0 and 2, there's a right triangle with a base of 2 and a height of 4. The area is 4. Also, from -2 to 0, the area is 4. But from -4 to -2, the area is -4. So we got 4 plus 4 minus 4 is 4. That's the area from -4 to 2. Negate it, we get -4. All right, another critical point was when G was 0. G prime was 0, which is f of 0, is x equals -2. So what's the area from 2 to -2 of f of t dt? Again, it's going to be the opposite of the area from -2 to 2. So let's look at the area from -2 to 2 and negate it. The area from -2 to 2, well, there's a triangle of base 4 and height 4. So the area is going to be 8. And that's, but now we're negating it, so we get -8. Okay. So -8. All right, the next critical point was at x equals 2, but clearly the area from 2 to 2 is got to be, oops, where is it? From 2 to 2 has got to be 0. You don't even have to look at the diagram. All righty, now let's extend the table a little bit. Some more critical points. At 6, we had another 0 for f or g prime. So what is the area from 2 to 6 of f of t dt? And let's see it. From 2 to 6, well, that's another triangle of area 8, isn't it? There you go, done. All right, so that's going to be 8. We don't have to negate anything because it's going from 2 to 6. Not 2 to -6, right? Then another critical point was g prime is 0 when f is 0 is at x equals 10. So it's the area from 2 to 10. And take a look at the diagram. I did it again. There you go. Okay. And from 2 to 10, well, from 2 to 6 it's +8, and from 6 to 10 it's -8. The area bounded by those triangles, right? The signed area for a definite integral. That cancels out to 0. So here we go again. We have another 0. And at the endpoint 12, what's the area from 2 to 12? Well, that's the area from 2 to 10 plus the area from 10 to 12, right? Well, from 2 to 10, it's 0. From 10 to 12, it's -4. So add them up, and you get -4. So now take a look at your values. What is the greatest value? On the right side of the column, +8. What's the least value? It's -8. Okay, so let's say, so we're going to write a sentence that says something like, let's see, absolute min is -8 at x equals -2. And absolute max for g of x is positive 8 at x equals 6. You can write that in sentence form, but that's basically the answer. All right, and part D. For x values between -4 and 12 inclusive, find all intervals for which g is less than or equal to 0. All right, well, notice from 2 to 6 it's positive. From 2 to 10 it's positive, except, because we're adding more and more negatives, but at 10 it's 0. But then from 2 to beyond 10 up to 12, we're adding negatives, right? So for between 10 and 12. Okay, so for x between 10 and 12, the integral from 2 to x of f to t dt is going to be negative. Now, look at this going backwards. From 2 to 0, that's going to be negative because it's in area 4, but we negate it. From 2 to -2, it's even more negative, so that's a -8, right? But then from -2 to -4, we get this negative area under the curve, but remember, we're changing the sign, so we're adding it, but we're not adding more than 4 to the -8, so it's still negative. So for the area from, the integral from 2 to x, for all values from 2 to -4 for x, are going to give you negative results. So, say so. Let's see how we're going to say that. 3D, g of x equals the integral from 2 to x of f of t dt is less than, did they want less than or equal to 0? Less than or equal to 0, okay. Less than or equal to 0, let's have it. For all x's, element of the interval from -4 to 2, because at -4 you get 0 and at 2 you get 0, so closed intervals. Union from 10 to 12. Now let me think about it. At 2 it's 0, at -4 it's not 0. So this is open here, and this is open here, sorry. But we did have 0 at 10, and we did have 0 at 2. So there you go. Whoops, have it. And you might want to write a little sentence explaining why, based on the diagram, okay? And that's it. All right, YouTube, I hope that was helpful. And so noSAGE today, not a live recording, a short recording, and just a SmartBoard today. So that's all she wrote. Bye-bye, YouTube.